What is going on, internet? My name is Lou and I make Linux videos and I put them on the internet. Tonight's video is going to be actually an update to the very first video that I ever put on YouTube on the Linux kernel. Now that video is pretty old. If you go over to my YouTube page and search my uploads, you're going to see that I uploaded the Linux kernel part 1 in February of 2011. And to date, it's the most viewed video that I have. It's one of the most commented videos that I have, and you know, it was a real cool video to make for me because it was the very first attempt at this whole YouTube thing that I've ever had. So, you know, tonight I'm going to show you an update to that particular kernel video, and it's going to be again on how to compile the Linux kernel the Debian or the Ubuntu way. Okay, so if you're on Debian, Ubuntu, or any derivative of those two distributions, this method will work for you. Okay, now a lot has changed since I made that first video. We had to add some PPAs because of some broken packages and all that stuff. That is not the case anymore. Tonight is going to be a very straightforward video, and you know, it's going to show you how to compile your own kernel. Now, why would you want to do something like this? Well, you know, we discussed it in that 3-part video series, but you know, for me, for instance, I'm on a desktop that I pieced together myself, and you know, I've got an SSD, I've got a specific configuration that I want to optimize for. Okay, so that's one of the reasons why I put together my own kernel. Now, I also wanted to use the BFS CPU scheduler, and that is not included in the kernel by default. So I mentioned this is the Debian way or the Ubuntu way. If we come over here to my About in Switchboard, you're going to see I'm running Elementary OS. This is, of course, based on Ubuntu 12.04, so this method will work on Elementary. Now, in terms of packages, what you'll need to install for packages, if you come over to my Blogger page, which again is linked in the video description below, I have a blog post that I entitled Lou's Ubuntu Cheat Sheet. Put that together some time ago, but I have a list of packages here under my commonly installed apps, and they include build essential, kernel packages, kernel package, lib ncurses 5-dev, bzip2, and fakeroot. Also Git. If you're going to end up cloning the kernel Git repository, you're going to want to use Git. Tonight I'm going to show you a different method, a little bit simpler, but let's get to it. So head over to kernel.org. This is the main site that houses a lot of the kernel sources, and as you can see, the latest stable kernel is 3.9.7. 3.10 is at RC7. You know, the final release is actually just, you know, imminent. It could be at any time now. And when it is finally released, if you want to, you know, get the latest and greatest in the Linux kernel innovations, you can compile your own. If your distribution is not something like a bleeding edge rolling distribution like Arch, or something like Gentoo, and you want the latest kernel, now you can put it together yourself. So what you're going to do is download the sources by just clicking this particular big yellow button. Couldn't really be more obvious than that. And it's going to give you a tar.exe file. You know, for the sake of time, I've already done that, and it's in my home directory. Now we want to get the BFS patch. This is completely optional. If you're not sure what the BFS patch is, I'm not going to go into great detail about it. It's a CPU scheduler patch. I'm a big fan. I've used it many times in the past, and I'm going to show you guys how to apply a patch to your particular kernel tonight too. So the way you download it, and I'm going to include a link to this in the video description below, just right click on the patch and you're going to select save link as, save it wherever you'd like, and that's it. Very simple. So what we're going to do, and I will show you a quick uname of my kernel. So if we do a uname, as you can see here, I'm running 3.9.7 BFS, and I added a special name to this. A BFS includes indicates the patch that I used. Ubuntu indicates the base system I'm using, and then the date I compiled it on. So if I compile multiple versions of the kernel, trying out, you know, different things, I can differentiate them by these tags. Completely optional. I'm going to show you how to add your own special name to the kernel itself as well. Now, if you add a name to the kernel, it'll also show up in something like this here. If you open up your system monitor, your own the kernel name will display here as well. So this process is going to create deb packages of your compiled kernel. What's nice about that is once you compile this kernel, if it's a stable kernel and you know it's one that you're going to use for a while, and you're going to reformat your system and try all different distros, if you find yourself on Ubuntu or a Debian or a derivative of those two distributions, you can use this particular kernel without having to recompile again because they're in a nice packaged deb file. So that's one of the benefits of the method that we're going to use tonight. So now that we've downloaded the kernel sources and we've also downloaded the patch, I'm going to create a directory to compile the kernel in. You do not have to compile in your source directory. You can, but it's not a requirement. For me, I just like to compile right out of my home directory, and I create a directory called kernel. So we're going to do that by executing mkdir kernel. So if we list out the contents of my home folder, now you see the newly created kernel directory. So let's move our kernel sources as well as our patch into that directory simply by using the move command. And okay, so now we've moved our kernel sources and our patch into the newly created kernel directory. What we need now is we need a base config. We need a config to use as a foundation for our kernel compilation, and basically this config is going to set certain base configurations, for instance, you know, your Ethernet, your sound, all that good stuff within the kernel to kind of get you started. Now the kernel does come configured, a very generic configuration, but what I always suggest using a base config. Now you can pull that right out of your boot directory from the distribution you're using. So if we put ourselves within the boot directory and we list that out, you can see that I have a few configs in here already. I am going to move this one right here, the 3.9.7 config. That was from my last compilation. So let's move that into the kernel directory that we created by using copy. And okay, so now that we've copied that into our kernel directory, let's list out the contents. We have our kernel sources, our patch for BFS, and our new config. So now let's untar the kernel source. We do that by tar-xvf. Now the next step is something I've been doing for a long time. This by no means is, to the best of my knowledge, necessary. From the reading I've done in the past, when the make file is running and the kernel is compiling, during certain module compilations, it looks for a directory called Linux. So I've always done this next step, whether it's still something that is good to do or not. To be quite honest, I'm not sure. I'm doing this out of force of habit. So I'm going to symbolically link our kernel sources to a directory called Linux. We do that by executing ln-s, our kernel source directory, and then a directory that now we're going to call Linux. If we list everything out, you see the Linux directory there. So let's put ourselves within the Linux directory, and now we want to get the source files prepared for compilation. The way you do that is running a make clean and make Mr. Proper. This should just take a second. Good, that's done. Now if you have a config, now say you've compiled a few kernels, you're using the same sources, once you run a make clean and a make Mr. Proper, it's going to clean out the config that you were using previously. That's why I didn't move the config in that directory at this point. Now what we want to do is we want to copy our config into the Linux directory, and we want to rename it .config. Okay, so that's how you do that. Now if we put ourselves back within Linux and we do an ls-a, which is going to list out everything including hidden files, we're going to see that there's our .config right there. Perfect. So now we're going to get into the configuration portion. So let's do a make menu config. Now, you don't have to use make menu config. You can open this up with a text editor if you want to and go through all the options. This is just a graphical way to do it. You know, so again, there's a lot of different ways to get to the same end result. This is just the way that I've done it, and I find it fairly easy. And until you familiarize yourself with a lot of these things, I suggest using this method. Reason being, as you can see down here at the bottom, you've got a nice option here that says help. You know, and for instance, our first option up here is it says 64-bit kernel. If you select help at the bottom and hit enter, it's going to tell you what that option means. And it says here, say yes to build a 64-bit kernel. So if you're on a 64-bit system, you want to build a 64-bit kernel, we're going to select that. Now, if you're on a 32-bit system, you're going to want to deselect that. And you're going to do that simply by highlighting this particular option and hitting N on your keyboard for no. So to start, we want to load our base configuration. How do you do that? Come all the way to the bottom, select load, and then enter the name of the configuration. It's going to automatically default to .config and just hit OK. So now that is, oh, you know what? We didn't patch the kernel. Let's exit, and we don't want to save anything. So we need to patch this first. We do that by executing the patch command, which is, you know what, let me, all right. So it's patched -p1, and then this guy, actually. And then what do we want to, we're gonna select our patch. Are we within the right? Oh, okay. Actually, you know what? We have to put ourselves within the Linux directory. All right, now we can execute that particular command. All right, and that's pretty much it. Hit enter. Hold on here. Patch -p1. Oh, okay. Oh boy, oh boy. Okay, so we gotta move the patch into the Linux directory first. So let's move 3.9. Okay, let's move the patch into Linux. CD into Linux. There we go. Okay. So we executed the patch command by patch -p1, that guy there, and then the name of the patch. You got to move it into the sources directory, or in our case, the symbolically linked directory called Linux. So we patched that. It tells us here all the things that it patched, and we're good to go. So now that that's done, we can run a make menu config. We can come back down over here where it says load and hit OK. So how do we know? First of all, if you were to read that output, it would say hunk failed at line whatever. If you try to patch the kernel and it tells you that something failed, then obviously the patch didn't go through successfully. And you can actually go through and see what line. It's going to tell you what line it was using a text editor or Vim or whatever you want to use, and then see if you can correct it. So in our case, everything patched just fine, and we know that it patched fine because if we come over here to General Setup, as you can see, the BFS CPU scheduler is now an option to enable within the kernel. You can go to Help, and this tells you exactly what the BFS CPU scheduler is. It's a scheduler for excellent interactivity and responsiveness on the desktop, solid scalability on normal hardware and commodity servers, and it's not recommended for, and it tells you that. It's currently incompatible with group CPU scheduler, so on and so forth. So say yes here. So that's that. Let's see if we come down here. Let's see. Now, depending on what config you're pulling from your distribution, it may be an older config. Now, if you're trying to use an old config with a very new version of the kernel, the old config is not going to have the same, things aren't going to be placed in the same areas. So you may have to, go through each of these options to look for certain things. But, if we come into enable block layer, I have an SSD in my system, and I want to use the Noop IO scheduler by default. So I'm going to come down to IO scheduler, and it's going to tell you which ones are included. Right here, default IO scheduler is Noop. Okay, so you simply select Noop, and that's it. Again, if you come over to help, it's going to tell you that, very basic of what the definition of what the Noop IO scheduler is. And so now, again, Noop or Deadline are the preferred schedules with an SSD. So I can build that option right into my kernel. Also, processor type and features. If we come down, processor family, normally this is set to generic, a 64-bit generic processor option. I have a Core 2 or newer Xeon processor, so that's the one I'm going to select. Let's see. You can get rid of a lot of these options. If you don't know what it is, I don't suggest disabling it. But multi-core support, you're going to want that if you have a multi-core system. Hyper-threading, you're going to want that, especially if you're on an Intel machine. Preemption model, I have a preemptible kernel low latency desktop. I want things as responsive as I can get them. I disabled Dell laptop support. I'm not using a Dell laptop, so I don't really need that. I could probably actually get rid of a lot of these AMD options because I don't have an AMD processor. So normally I could get rid of that. Let's see here. Timer frequency, this is usually defaulted to 250 Hertz. It really depends on whoever put the kernel together for the distribution. I have it set to 1000 Hertz. If we come down to device drivers, here's a good example. If you're using an old config, like the config that comes with Ubuntu 12.04, the layout is different within the config. If you have something like a webcam, like what I'm using here, you have to come down to, let's see, multimedia support, and right here you have to enable this camera video grabber support, and media. If you come down to where it says media USB adapters, here's a lot of the webcam stuff. So that's where you enable that. Now if something has an M by it, it means it's going to compile it as a module. It's not going to include it in the kernel itself. It's going to compile it as a module. So basically, what does that mean? That means it's not going to be loaded by default unless it's in use by the system. So for instance, if my webcam isn't plugged in, and then I boot my system and then plug my webcam in, the module is going to load. But it's not going to load that module by default when the computer boots. Okay, so if you don't want something included within the kernel, you don't have to some things have to be compiled within the kernel itself, but a lot of these things, especially for peripherals, you can compile them as a module and keep the kernel size very small. Okay, so that's that. Down here where it says graphics support, again, I can get rid of a lot of this stuff. I have a NVIDIA card, so I don't need any of these ATI things. Of course, I'm going to need the Novu driver because that's the open source driver. Although I'm not even using the Novu driver right now. I'm using NVIDIA's proprietary driver. But, again, I don't need a lot of these ATI options. I probably could have gotten rid of them. But quite honestly, it's not going to do any harm by compiling them, especially if they're compiled as modules. So no big deal. Kernel hacking, you don't really need anything here. in kernel hacking. I've disabled most of it. If you're not going to be debugging the kernel for any reason, there's no reason to add any of this stuff in here. It's unnecessary and you don't need it. File systems, as you can see, here's all the different file systems. ext4, of course, is, you know, primarily what most distros are using these days, but it has a lot of the other stuff in here, Btrfs, all that good stuff. You know, so for me, I changed, let's see, I changed a lot of these, not a lot of these things, but again, to meet the needs of my particular system. The new BIOS scheduler, I changed it specifically to identify with an Intel processor. I changed the preemption model. I changed the timer frequency. I enabled the webcam support for my webcam. Let's see. I'm trying to find a specific option in here. It's escaping me at the moment. CPU frequency scaling. Okay. Here's all your CPU governors. Okay, we've enabled scaling. Okay, so but the default governor, as we can see here, is performance. You know, if you're on a laptop, you don't necessarily need your CPU flat out as fast as it can, you know, the highest clock speed that you can set it all the time. You may want something like, you know, on demand, which is going to scale your CPU frequency based on the load on the system. So if you're not using something, you know, super intensive, it may scale it way down, and then when load comes on the system, it may scale it back up again. Generally on demand, if my memory serves me correctly, it either scales it to as high as it can go or as low as it can go. Or you can have something like power save. You know, if you're on a laptop, again, you may want something very moderate, especially if you're not going to be doing any heavy CPU intensive tasks all the time and you don't really mind if things, you know, again, if you select something like power save or conservative, you know, you may see a little bit of lag here or there because, again, you're messing with this frequency and the clock speed of your CPU. So if it's not pinned down all the time as high as it can go using the performance governor, you may see a little bit of that, but you may get battery savings if you're on something like a laptop. Okay, so that's where you would change that. Here's where you have your hibernation, or also known as suspend to disk. Here's your standby feature, or, you know, suspend to RAM. So this is where you get a lot of this stuff here. Of course, your networking support. So you can come through and, you know, you've got wireless here. Here's all the different wireless options. So you can choose any of those. Okay, so once you're done configuring, okay, and again, use the help if there's anything that you don't know about. You're going to hit save. It's going to ask if you want to save your config. You hit OK. You can exit at this point. Now we're ready to actually compile the kernel. Okay, so we're going to compile by running. Now you never want to compile a kernel as root. Okay, so we're going to use fakeroot for that. So let's do that by executing fakeroot, and we're going to do a make package, and we're going to add the J flag, and I'm going to do 9. I have 8 CPU cores. So the general rule of thumb is however many CPU cores you have plus 1. That's what most of the documentation on the internet are going to find. You know, you want to use some crazy number. I've compiled before using 100, you know, simultaneous jobs at one time. Doesn't make a whole lot of sense, but what have you. 9 is kind of that number for me. If you have a dual core system, you could do something like -J3. So next we're gonna do -- init rd, and then to add a custom name to your kernel, you're gonna do -- append to version equals -- you can do loo test bfs, and then we need a kernel image, and we need kernel headers. Hit enter. Once you hit enter, it's going to start to run make. Once that starts, your kernel is going to start compiling. Now, the time that it takes for this kernel to compile is, strictly going to, be based on your system hardware. What kind of specs do you have? So, what we're going to do is we're going to pause the video. When I come back at the end of the compilation process, I'm going to show you the Deb packages that were created and how you would install them. All right, so we'll see you guys in a minute. Okay, and we are back. So at this point, your kernel should be compiled. You should have 2 Deb packages, and we're going to take a look inside my directory that I have all my stuff in. So we're gonna copy ourselves within kernel, list everything out. Here's the 2 Deb packages. To install these, you're simply going to run sudo dpkg-i and then *.deb. Hit enter. That's it. It's going to install your kernel, and it's going to update your grub. So you should be able to then just reboot into your new kernel at that point. And guys, it's literally that simple. It's not difficult to put a kernel together. I highly suggest if you're interested in Linux, if you're interested in really learning the ins and outs of how your system works. Now you have to remember, Linux is not an operating system; it's a kernel. So what we have here is GNU/Linux, which is the GNU platform on top of the Linux kernel. So if you really want to learn Linux, you gotta start to kind of dissect the kernel and see how that works. So that's how you would install your kernel. Now, if you're using a proprietary video driver, like say the NVIDIA driver, you'll have to recompile that driver for the new kernel version. That's a whole nother video topic. I'll probably make another video on how to do that. This is simply just how to put your kernel together and install it on your system. Hopefully you guys like this video. If so, do me a favor, give it a thumbs up. I can do more kernel videos in the future. I know I've got a number of them on my system, and I've showed you how to compile them on. I know I've done some stuff when I was using Fedora. I've also done some Android kernel stuff, and now I'm doing the Debian way. So, leave a comment in the comment section below, and until next time, we'll see you guys later.